Right, with graph transformations, okay, there are a number of different types. First ones we're going to consider here in this homework is the type where you have f of x plus a, okay, and f of x minus a, alright? So in this case here, or in both cases, we need to respect the fact that actually when you have a graph and they call it f of x represents the y value. So if we're adding a to it, what actually happens is you are increasing the y values by this amount a. So the graph ends up shifting upwards, okay? If you are taking the value away from f of x, taking the value away from y, shifting the graph downwards, okay? The other type of transformation is when the x value is affected, okay? So you could have something like this, right, where the x value is affected and then you take f of it, okay? So the y value actually stays the same, nothing happens in the vertical direction, but there's movement along the x-axis. As you can see here, the x value is affected here, it's inside the bracket. Now one thing to note, which is really important, when it's inside the bracket, you always do the opposite, okay? So you're always doing the opposite along the x-axis. So where it says here, add a, you actually end up shifting this way, the amount a, so you go in the negative direction. And then, when you have, of course, then this, and you have a negative value for a, alright, you actually go positive shift in the x-axis. So that's important to remember there. Outside the bracket, okay, you affect the y value, you affect f of x, you're adding a to the curve so it shifts up, taking away a value, it shifts down. Inside the bracket, you affect the x, there's a movement along the x-axis. The y value stays the same, it does not go up or down, but the graph shifts along the x-axis. And of course, you go the opposite way. So if it's plus a, you go in the negative direction along the x-axis, minus a, you go in the positive direction. Let's look at number 1 here. It says, draw f of x plus 5. Hence, write down the number of roots to the equation f of x plus 5 equals 0. Well, let's not worry about this. Let's try and draw this first. You'll notice here, f of x plus 5, you're adding 5 onto the curve. So the y values are going to increase by 5. It's going to be shifted up. All you need to do is realize it is going to be shifted up, so we can have the same sort of axes. Okay, maybe I'll have a little bit more for y here. Okay, but there's no movement along the x-axis. Okay, so you can consider the same sort of axes here. But what happens, of course, here when you're adding 5, this value here, okay, the y value, you're going to need to add 5 to that. If you add 5 to minus 4, you end up with 1, yeah? If you shift that up 5, you're adding 5 onto that, you end up with 1. Now the x value stays the same, so that's going to be 2, 1 there, okay? X value stays the same, it's just the y value, you're adding 5 to it. And then that's the minimum point of the curve. So you draw your curve like that, and you draw your curve like that, and we're done. We label this here, and we'll call this f of x plus 5. Now in a question like this, let's see if there's any other information we can fill in. Well, what's important here, of course, is recognizing what's happening here. It crosses the y-axis at 0. Now if it's shifting up 5, think about where it would cross the y-axis up here. Of course, it will cross the y-axis there at 5. So you could put that value in there because we know that. This value here, 4, 0, well, that will shift up to 4, 5. That'll be up there somewhere, but that's not really important. That's just a point up here somewhere on the curve. That's not important. This is important here, though. So there's our transformation, shifted up 5. Now it says then, hence write down the number of roots to the equation f of x plus 5 equals 0. Now if you've got this graph here, this is your f of x plus 5. If we were to set it to equal 0, okay, and you need to realize now, when they say f equals to 0, okay, then they're talking about the overall thing equals to 0 in terms of the y values. So it's equal to 0. And if we look here, okay, where the y is 0, which is the x-axis, it says how many roots. In other words, when it says roots, you know, how many values have we got here? How many times have we got this curve hitting 0? And it doesn't, doesn't it? It doesn't hit 0 at all, okay? So we'd say no real solutions, okay, or no real roots. There are no solutions where it's equal to 0. Question 2, it says then f of x minus 2. Now in this case, the f of x, you were taking away 2 from it, the y values are shifting down. So we're going to draw our y-axis and x-axis maybe a little bit more for the y-axis in the negative direction. Okay, in this case then shifting down 2, so the that's going to be -6, isn't it? That's going to be -6 here. The x value will stay the same. Okay, so you're going to have your graph then. Okay, now in terms of what else we can label, well, we don't know what that point is there. Okay, we don't know what it is because all we know about is that point there. But of course, when that gets shifted down 2, it will end up being 4 minus 2, which is down here somewhere. So we don't know what that is. It doesn't matter. Okay, don't worry if we don't know it. We know the minimum, and it's important to have that there. But we also know what this is as well. Okay, because it's on the y-axis. If it goes down 2 from the origin, it'll end up being -2 there. So you've got that. And then it says, hence write down the number of roots to the equation f of x minus 5 equals 0. Now this time where it's equal to 0, of course it crosses twice. Okay, so you can say that are 2 real and distinct, of course distinct meaning different, roots. Okay, and that's our answer done there for the second one.